So now we have a Hello World application, but we need some sort of Android device to run it on. And we have a couple of different options, which I've run down in this list. So the first option is to attach it to a real Android device, either an Android phone or a tablet. And the biggest advantage of doing it this way is that, first of all, your performance is going to be the best doing this because the code is going to be compiled to run on the native device itself. And it's also going to be the most accurate way of testing and judging the results of your app because you're going to be running on the actual device that most people are going to be running on. And finally, you know you're going to do this eventually anyhow because you wouldn't be taking this class if you didn't want to run on your own device. So it's only a matter of time. Now, there are some disadvantages to running them this way. When you're running on a real device, you only have one real device with one particular set of hardware and one particular operating system running on it. So if you want to test for a bunch of different platforms so that you can, sell your app on the marketplace, you want to make sure that it actually runs on a bunch of different configurations. And that's not something you can do if you only have one device available. There are a few extra steps that you have to go through in order to get your Android device properly configured. And the most difficult step is actually finding the right drivers. Sometimes that can be a real challenge because there are a bunch of different manufacturers that are making Android apps, and some of them are, let's just say, they're easier to navigate than others. Your second option is running a native emulator. So your computer is using an Intel x86 64-bit processor, and the Android device is also using the same processor. And so instead of having to go through a lot of complicated translation from one machine language to another, the Android emulator can run natively on your desktop computer. So the advantages of doing it this way is that, first of all, you're going to get good performance because there doesn't have to be that extra step of translation. Since it's a virtual device, you can have a variety of different configurations so that you can make sure that your app is compatible with a number of different platforms. And there's also some support for OpenGL ES, which is the graphics library, versions 2.0 and 3.0 that have vertex and pixel shaders. There are some disadvantages as well, though, and the biggest one is that the native emulator that's built into the Android Virtual Device Manager only works with Hardware Accelerated Execution Manager, Intel Hardware Accelerated Execution Manager, which only works on certain processors, certain Intel processors that support the virtualization instructions. If you don't have one of those processors, you're out of luck. So I have an AMD processor on my computer, and so I can't do this. Another disadvantage is that the binary libraries that you use for your emulator are going to be x86 based, but the actual Android device that you're going to be running on is probably going to be ARM based. And that means that you need two different versions of these libraries. Usually it's not a problem, but in some cases when you're linking to precompiled object code, you're going to need to have two different versions of the libraries built. Because the assembler code for x86 architecture doesn't look anything at all like the assembly code for ARM architecture. And so that will just make it really difficult to run certain applications using native emulation. One of the easier ways to get started is to use a non-native emulator, which is available directly in the Android Virtual Device Manager using emulation of the ARM platform. So this is going to work on pretty much any computer, at least anyone that will run Android Studio to start with. And you only need the ARM libraries because they're going to be emulated on whatever desktop computer you have. You can test a variety of configurations because, once again, you can set up as many virtual devices as you want. And it's built right into Android Studio, so it's relatively easy to set up. The big disadvantage is that it's very, very slow. You will run this emulator and you will be waiting a long time for it to do fairly simple things like boot up. And finally, there's sort of a disadvantage in that it doesn't support OpenGL ES 2.0 or 3.0. It only supports OpenGL ES 1.1, which is the version that doesn't have pixel shaders and vertex shaders. So if you're doing a lot of graphic stuff, if you want to do games or things like that, and you want a realistic emulator, this isn't going to work for you. It's just not going to support the extensions to OpenGL that you're going to want to use in your game. And the final option, and this is the one that I'm going to mostly use, is a third-party native emulator. So once again, I can't use the native emulator that's built into AVD because I don't have an Intel chip that supports Haxum. But I do have an AMD chip that will support native emulation using Genymotion. So Genymotion is a third-party application that's an Android emulator, and it works really well. So it's got good performance. You can build a variety of different configurations. Works on most computers, not just Intel computers, and it supports OpenGL ES 2.0 and 3.0. So the big disadvantage is that you have to register with Genymotion. They have two different versions of the Genymotion emulator. There's a free one that you can get as long as you register. And then there's one that you're going to use if you're a business. Well, that one costs money. It may also not be as accurate as the AVD. I think they generally use the same kernels as the Android Virtual Device Manager does, but third-party software is never going to be as robust as supported software. Particularly in open source, you have a much bigger community that's working on AVD and Android Studio than you do have a community that's working on Genymotion because it's closed source, so people can't download it and can't improve it. And as with the Intel solution, the native emulator that's built into Android Studio, you have to build both x86 libraries as well as ARM libraries. So those are the four alternatives that we're going to be looking at, and in the subsequent videos we'll actually look at configuring them and getting them to run.